Okay, today we'll continue on in ggplot 2 and all of that. Before we get started though, I am still grading your midterm exams. Okay, there's a lot of you and it takes a while to grade. So I'm still grading. As soon as I'm done grading, I will post your scores, let you know how you did. And then you can come. And then after the grades are posted, you can check out the exam and see how you did, or pick them up in section and things like that. Okay. Okay. I don't know. I guess if you want to give me any feedback about the exam, you may. Okay, well, I'll say a few things before I post grades. Okay? And yeah, okay, feedback, yes.
I just wanted 10 more minutes, maybe, like 5 more minutes, or like one less question, maybe it would have been good.
Okay. Yeah. That's it's always a struggle to write an exam of the appropriate length of time. You take it yourself, you time yourself, and then you like multiply it by 3 or whatever, and you try to gauge how things are going. I know, some of those things were purposely like badly written code that made you think, and yeah. So before I post the grades, and I'll also say the same thing after I post the grades, okay? Number one, it's just a test, one test, okay? It's worth 15% of the grade in this class. 20? Okay, 20%. I can reduce it to 15 if we need to. All right. I shouldn't open my mouth, huh? Okay. All right. Well, it's just one test in this class. I guess I said the wrong thing, so now I'm like held to it. But okay, it's just one test, and then it's like one class, right? And like, does this class really matter? Like, no, it doesn't. All right. Like, again, your academic performance has nothing to do with who you are as a person. We should not draw our validation and our self-worth from test scores or these types of things of performance, but rather we should always be looking to just do our best and improve ourselves. And I feel like most of you, almost if not all of you, just did your best on Friday, and that's all I can ask for. And so I'm proud of you guys for that. Okay. When you get your scores back, some of you will be happy, and some of you will be less happy. And again, it's okay, all right? The format of the test is a little bit harsh in that, you can understand most of your concepts, but because of just some poorly written code, maybe you lose some things. But I do feel, I always want to defend the form of the test, because I do feel that in the real world, when you are coding, you always run into situations where you are expecting your code to do one thing, it's doing something different, and the computer doesn't tell you why. It just follows the instructions, and you have to be able to go through and understand where the code is doing the wrong thing, even if it's not necessarily throwing an error. Okay, so a lot of these code things, they will not throw an error that says exactly where the code is going wrong, but you have to actually read through these things line by line and say, oh, this is where I've made the wrong assignment to the wrong thing. And and so I still defend this form of the exam as much as people hate it, because that's what debugging looks like. It's a very tedious process, and debugging sucks. Everybody, nobody's going to say that's the fun part of programming, but it's also a very important part. And so I still defend just the frustrating nature of the exam. And it's okay. This is always something that you can get better at, right? If you did bad on today's test, that doesn't mean you're going to be forever a bad programmer, okay? the more you learn and more you expose yourself to R and the language, you will just become better, all right? And so don't see your performance on this test to be some judgment of your skill, okay? All right, anyway, I'll probably give a similar spiel after the grades are posted, just to remind you of your humanity and your worth, okay? And I'm totally sincere and genuine about it, okay? Also, you know, it's 6th week. I can't believe it's already 6th week, and I know the quarter goes by, and I know it's also during this time of the quarter that things start to feel extra stressful and can be burdensome. You've got midterm fatigue and all of these other homework assignments and projects and stuff building up. And I want to also declare that it's okay if you have to scale back your workload, right? And if you find your mental health suffering through it, you should seek counsel and help. There are resources available on campus, and I want to encourage you guys to seek those things out if you find yourself under a lot of stress and your mental health is suffering for it. Those things are available. And if you are doing great this quarter, then excellent. I'm very happy for you, and I would encourage you to, you know, if you have the capacity and energy for it, to try to be a support for you know, your friends and peers who may not, who may be struggling. So, okay. Anyway, that's say that. Okay, let's talk ggplot 2 and the grammar of graphics. Okay, so we covered. Where are we? Oh, of course. All right. Let's see. We are. Okay. I think we left off here at the basic ggplot geometries. And so, yeah, for today's lecture, I'll just talk about geom point, geom line, and geom bar. These are going to serve kind of, I think, the basic elements of most of your plots. Of course, there's many other plots that are possible. You can make violin plots and, I don't know, all sorts of other things. But I think because we're accustomed to seeing points on a 2D grid, also lines, these are worth emphasis. And again, everything else you can explore in the ggplot documentation. And I also highly recommend the R Graphics Cookbook, which is linked in the course syllabus. Okay. So we'll start with bar graphs. Bar graphs have you got one column representing the x position of each bar. Generally, that will be a categorical variable, but it could be numeric as well. And then you'll have another column representing the height of the bar, okay? And so here we've got categorical variable that says control, treatment 1, treatment 2, and then the numeric value, okay? And we will plot these using geom_bar and stat equals identity. It means use the value in this column to form the height of the bar. The default behavior of geom_bar, of the bar geometry, is to go through the categorical variable and count out how many times a certain category appears. So if you've got a data set of 1,000 observations, it will see how many times did category control appear, and if it appears 270 times, then it will produce a bar with a height of 270. So that's the default behavior of geom_bar. And so if you have a column with numbers in it and you want the numbers to be the height of the bar, you have to say stat equals identity after you map the weight to the y column. And so here we have it. The group is being mapped to the x-axis, the weight is mapped to the y-axis, and we're using identity to determine the heights of the bars. you might have two categorical variables, okay? And you might want to display kind of both of those categories together. And so here, I guess we're looking at cabbage data, okay? And so we will determine the x by the date. So we have three dates, date 16, date 20, and date 21. The weight is going to be the height of the bar that we use. And then we have two cultivars, cultivar 39 and cultivar 52. And we will change the color or the fill color of our bars using the cultivar. We're mapping cultivar to the, sorry, just batteries died. Okay, so we'll map the cultivar to the fill, and that's what we have. When you're talking about bars, there is the color. The color is the kind of the line that outlines the bar, and then the color that goes inside the bar is called the fill. Okay. Generally, when you're talking about like lines and things like that, you'll have the color of the line, but then if you're shading the inside, that's known as the fill. Okay, and then we use position equals dodge because the default behavior is to stack them on top of each other. And so when we do that, we get what we wanted. We have our three different dates across the bottom. We have our two different cultivars represented likewise. Okay, this is the kind of it shows the default behavior of the bar plot. Okay. And so here there's the diamonds data table, okay, data set. And in the diamonds data set, there are almost 54,000 rows, okay? So, you know, you want to buy some diamond jewelry. The diamonds are evaluated on the carat, which is the size of the diamond. It's cut, how well did I don't know, what do you call it? What's a person who cuts diamonds? What are they called? A diamond cutter? Okay, all right. Well, okay. How well did the professional diamond cutter do at his job or her job? And they either did a good job or not. It's actually, they did a good job, a very good job, or an ideal job, and things like that. Okay. And then the color is like, is it clear or blue or yellow or something, right? Yellow, nobody wants a yellow diamond, but anyway, so there's, and then clarity, right? And there's all of this stuff, and then we just want to go, all right, well, can we summarize something? And so let's say we want to know how many diamonds get ideal cuts and whatnot, and geombar without any arguments, no stat equals identity. It just goes through this column cut, and it says how many times did I see ideal, and it saw it 20-something thousand times, 21,000 times, and then premium cuts got I don't know, 14,000. So stuff like that. Okay. And then if you want, here we are looking at some state information, and I think this is like population changes between one census and another, right? We do our census every 10 years, and then we say, oh wow, Arizona's population grew 24.6% in the last 10 years, and Nevada grew 35%, and stuff like that. So here we're looking at this data set, US population change. We are ranking the change. Rank goes from least to greatest. So if you want the 10 largest, you have to say the change is greater than rank 40, because the biggest numbers get ranked at the bottom. Okay, and so we look at this, and it has filtered out or subset the data set accordingly. And then, so to map this, what we're going to do is we're going to say, we want to put the abbreviation column across the x-axis, which is what we have. We are going to have the height of the bar determined by change, so we're going to say y is equal to change, and inside geom_bar we'll have stat equals identity. And then we want to shade the fill determined on the region, either the south or the west, because those are our top 10 state growths happened either in the south or the west. And this is what we have. Okay. Here, I have the fill mapped to the categorical variable region, which is either going to be south or west. Here I'm mapping fill to change. So y is change, which is the numeric variable, and it's the height of the bar is determined by change. And here I'm also mapping a numeric variable to change, okay? And ggplot recognizes this and says, oh, you've mapped a numeric variable to the fill color. So now I'm creating a gradient where the largest number is going to get light blue, and the smallest number gets a dark blue, almost a black, okay? And you can customize that, but this is kind of the default gradient that it produces, all right? And so here, this is the same bar graph as before, but the shading has changed. And when you have something kind of arranged like this, it might make sense to arrange them from least to greatest or greatest to least, okay? And so to do something like that, we throw into the x aesthetic mapping, we say reorder the x variable and reorder it by change. So here we're saying take the abbreviation, reorder it by change, and so it's going to go from smallest to largest, and we can see the gradient in the colors right here matches closely to the gradient in the kind of our guide. Okay, if you want different colors here, this is, I looked up UCLA's official, it looks terrible on this projector, but it looks better on my screen, okay? Apparently UCLA has an official style guide for the colors, and just look up UCLA style guide, and these are some of the official colors and whatnot. So anyway, ta-da, all right. You want to change the custom scale? Oh, the text got cut off here. So all of these things I don't remember off the top of my head ever, okay? I always have to go Google ggplot customize the scale or something like that, and then I'll find the appropriate thing. So, but just know that all of these things are possible. Okay, I can't find it. All right, let's do this. Do this pop. Okay, so here we go. Reorder, customize colors for the continuous scale. So you just say scale fill gradient, and you'll say low is red and high is blue. And ggplot does its best. Okay, so it says, okay, going from red to blue, and it should go from purple, but there's actually a huge jump here, so we miss all kind of the in-between colors between this, what do you call this, magenta. All right. All right, let's talk, and then there's all sorts of other stuff you can do, but this is probably covers most of the things you want, right? I suppose you could have a second variable in the outline of the bar, but then that's like information overload, right? And it gets cluttered and ugly. All right, line graphs. Okay, so here I've got two numeric variables. I've got time is x, demand is y. We're going to do that mapping. Time gets mapped to x, demand gets mapped to y. Add a line here, and ggplot says, all right, I did it, okay? And there you get a line graph. Let's say you want to draw multiple lines, okay? And so you've got like a categorical variable. And so here, this is like, I don't know who thought of this experiment, but apparently we want to know how does the source of vitamin C affect how fast the teeth in a guinea pig grows, right? So you got these little like rodents. Guinea pigs are rodents? What are they? They're like overgrown hamsters, right? So, and then they're measuring how long these teeth are growing, and they either gave them vitamin C pills or orange juice, and apparently it makes a difference. Maybe. It's difficult to say with 3 observations. So we do this, and so to do this, to do the mapping, we're going to map the orange juice to like some property of the line, maybe the color of the line, and then we will say map the X to the dosage, and then the tooth growth length to the Y. Right? So we said dose gets mapped to X, length gets mapped to Y, and then the color of the line will be the supplement type. Right? And so we get geom underscore line, and then you get this red line here and the teal line over here, or I don't know what color this is. Salmon? Okay. And it makes a nice little key for us. Okay. If you're going to print things out, right, and you only have a black and white printer, then color is not going to do you much good. So you can map something to line type, right, and it will do like a solid line or a dotted line or whatever. Okay. You can also change line width, but then you'll have like this really thick line and a thin line, and that could be distracting. So I think if you're going to try to show multiple lines, then line type makes sense, okay? But I think probably it's hard to distinguish between more than 3 line types. At 4 line types, it's like how many kinds of dotted lines can you make, and it gets difficult to see, right? So, okay, well anyway, you have that. Use color if you're going to have more than 3 lines. I guess that's about it for line plots. Let me think. Yeah. Okay. Scatterplots. This can be a lot of fun, right? So we have a data set that looks at how old some people are. So we're looking at kind of these teenagers from 12 to, it looks maybe about 11 to 18-ish, okay? And so we've measured their age, and you say you're like 14 exactly, or 14 in 1 month, or 14 in 2 months, or something. And then we measured how tall they are in inches. And so we are mapping the age to X and the height to Y, and we say add some points, geom underscore point. Okay, so I think I'm hoping by this point this aesthetic mapping portion is making sense, okay? Because this is the hardest part to get used to in ggplot, is the aesthetic mapping, how we map one variable to a certain aesthetic attribute. Okay. If you want to change these things, you can, as a setting, so this will change all of the points being drawn. Okay, so there's no data information being conveyed in the shape. So you just say shape equals 21. And so if you're curious, you can always look up our plotting characters. And this is kind of these are probably all the different. Is there a bigger one here? Kind of a listing of the different plotting characters that you can do. Okay, so from squares to circles and things like that. Okay, so you got that. Oh, is it different? ggplot point shapes. Let's see, quick reference. Oh, these are the ggplot point shapes over here. Look like they're the same. They're the same. Okay. If you want bigger dots, you can just change the size setting. Okay, so here I'm saying size is equal to 3. So this is the same exact plot. I just made this dot sizes bigger. And it kind of like, the plot feels entirely different, but it's not. It's exactly the same. Same exact information. Okay. If you have a categorical variable, okay, you can map that to another aesthetic attribute. So here in our data set, we observed only two sexes, M and F, and we mapped that to color, okay? So as far as this data goes, and so we can see these two colors, and what we see is, I mean, I think kind of just visually, I think the data reflects what we already kind of suspect, or at least maybe because I already suspect this, I'm more prone to view this in the data, my confirmation bias. But you know, around age 12, it seems like the red and blue dots are fairly mixed, okay? But then as we approach age 16-ish, it seems like the blue dots tend to be higher than the red dots, okay? Maybe I'm imagining that, but it looks kind of like it, right? Okay, which makes sense according to my experience of the world. All right. Again, if you have only a black and white printer, you can map the shape of the dot to the color. I mean, not the color. You can map the shape to the variable, categorical variable. So now we have circles and triangles, and this hurts my eyes, but there you go, right? Oh, can you imagine if size was 1? Oh, that would be terrible. But so if you're going to mess with the shape, I think it makes sense to increase the size for visibility, right? But the pattern is much kind of like the being able to separate the two categories. I think is easier with color than it is with shape. I can't detect any patterns here. Yeah, question.
Would we know like whether to put it inside the AES or the geo? Like for size, I don't know. It feels like you should put shape inside GeoPoint, but you don't.
Yeah, you can. You can put shape inside GeoPoint. You have to do AES though, okay? You have to put shape equals sex inside AES inside GeoPoint. You can do that, okay? So there is an aesthetic mapping for the entire plot, okay? This is kind of the base mapping, so we'll explore this in a few slides. But this AES represents the aesthetic mapping for the entire plot, and then this says draw geometries, in this case points, according to the kind of the setup in the plot, okay? In a few slides, I think I'll try to address this, but if you wanted to, you could put in AES color equals sex inside GeoPoint, okay? And then you'd also have size equals 3, but that goes outside of the AES because it's not an aesthetic mapping. It is a setting. There's no data attribute being mapped to the size, okay? Of course, you could map some data attribute to the size. So let's say, here, let's, okay, where is Gapminder? Is that the thing? You guys know about Gapminder? Yes, no? Oh man. All right, your homework, not really, sort of. Oh, wait, I don't want to go to YouTube and you see all of the videos I'm watching here now. We'll go to TED, and I was watching people playing video games. All right, Hans Rosling, he did this TED Talk back in 2006, okay? So this is like ancient history now, okay? But, and Hans Rosling he has died since then. But this was in 2006, this is 12 years ago, which for me doesn't feel long ago, but for you, that feels like a long ago because you were in elementary school, right? So, anyway, he represents all of these. Okay, so this, we're just going to skip this thing. Okay. Is this what we want? No.
Different time to invest, and here it seems that there is a gap between OECD.
Okay, so here we are going to look at, I'm going to just show you the clip that was amazing back in 2006, okay? We are looking at the relationship between how much money, the GDP,
more or less like this. And if we look at it,
okay.
how it looks the world.
Oh my gosh, why can't I pause the video? Okay, so what we're going to see, all of these different dots represent a country, okay? And the color of the country represents which continent they are in, okay? I think yellow is Asia and what is this? I don't know. Okay, I don't know all of the country colors, but I'm pretty sure yellow is Asia. All right, and the size of the dot represents the population. So this big yellow circle would be China, okay? And this one, okay, so I don't know all of these other. I know this one is China, all right? All right, and then, and this is in 1966, we are looking at GDP per capita, right? So this is like how much economic wealth is like a measure of economic wealth, right? So like the United States has consistently had very high GDP for the last 100 years. And then other nations, such as China, what we will see in this video, has gone from a fairly low GDP per capita nation to a fairly high GDP per capita per nation, okay? And the vertical axis is childhood survival, okay? So basically this means countries where many children died in childhood would be appear here, and then countries where the children survive very well is going to be rated up here. It's on a log scale. So anyway, we have multiple aspects being displayed in this single plot, and yet our brains are somehow able to kind of keep track of this. It doesn't feel overwhelming to see this, right? We see these different the size representing kind of the population, and then the different colors are associated with the continents, but I don't remember I don't remember it offhand. But let's see. Can I plug this in here? And will you guys hear this? This is worth. I'm afraid I'm gonna explode our ears, but let's try this. Okay, all right. We'll hear Hans Rosling give his kind of little brief.
For a long time, but they come out after 10 years very differently. And there is Latin America. Today we don't have to go to Cuba to find a healthy country in Latin America. Chile will have a lower child mortality than Cuba within some few years from now. And here we have high-income countries in OECD, and we get the whole pattern here of the world, which is more or less like this. And if we look at it, how it looks the world, in 1960, it starts to move, 1960. This is Mao Zedong. He brought health to China. And then he died, and then Deng Xiaoping came and brought money to China and brought them into the mainstream again. And we have seen how countries move in different directions like this. So it's difficult to get an example country which shows the pattern of the world. But I would like to bring you back to about here at 1960. And I would like to compare South Korea, which is this one, with Brazil, which is this one. The label went away from me here. And I would like to compare Uganda, which is there. And I can run it forward like this. And you can see how South Korea is making a very, very fast advancement, whereas Brazil is much slower. And if we move back again here, and we put on trails on them like this, you can see again that the speed of development is very, very different. and the countries are moving more or less in the same rate as money and health. But it seems you can move much faster if you are healthy first than if you are wealthy first. And to show that, you can put on the way of United Arab Emirates. They came from here, a mineral country. They catch all the oil, they got all the money, but health cannot be bought at the supermarket. You have to invest in health. You have to get kids into schooling. You have to train health staff. You have to educate the population. And Sheikh Zayed did that in effect.
Okay, you get just a taste today, all right? You can watch the rest of this. Look up Hans Rosling, and he had several, I think a few TED Talks, all kind of talking about global economics and health and worldwide issues and things like that. And his website, Gapminder, allows you to kind of do these visualizations and things like that. And we can do the similar kinds of visualizations with ggplot, representing multiple aspects of data in a single plot. And again, you know, the whole point of visualization is to be able to provide information to the viewer in a way that makes sense to them. You don't want to provide 50 variables, even if you can. Like, you might be able to find, like, maybe not 50, but like you might be able to find like 12 different variables that you can map to different aesthetic properties. But that's gonna be like too much for the brain to handle, right? So if you're gonna do something like color, do like 4 or 5 colors. You don't wanna have like 50 colors. That's too much to keep track of. Size should be associated with something that makes sense for size, such as, you know, population and things of that nature. And so always kind of think about how best you can represent these things. Okay, so that covers the point geometries, and then this is kind of the other important aspect about ggplot, is that you can have multiple data frames or multiple sources of data represented in the same plot. Okay, and so let's say I want to create a line graph of sine of x. Okay, to do this, I would need to create a tidy data frame where one column contains my x-axis values and the other column will contain my y-axis values. And it's just going to be kind of like, you know, at x equals 0, sine is 0, and as x goes up to whatever pi over 2 is, it's going to be at 1, and then as x goes to pi, it's back to 0, and then at 3 halves pi, you're at -1, and so on. And so all I'm going to do is I'm going to just create a sequence from 0 to 6. I guess I could do it in 6.28, a length of 200, and then all I'm going to do is just, I did the cosine. I said sine here, but I did the cosine. Whoops, okay, so forgive me. So it'll just be shifted over, right? Okay, so we've got this, and then and I create a data frame where I've got x and f of x, and we're going to map x to the x-axis and f of x to the y-axis. And here I'm going to say add a line geometry, and what I want for a setting is I want my line to be blue, and I want my line thickness to be 1. Okay, so sorry, this is actually cosine of x. All right, and there we go. All right, so the cosine of x looks like that. What if you had some data points to plot or add to this? Okay, here I'm just creating some a random set of x and y data points. So here I'm going to create a sequence going 0, 0.5, 1, 1.5, 2, 2.5, all the way up to 6. So I've got, what's that, 13 data points, okay? And then here I'm just randomly sampling values from the normal distribution. Okay, so this will just give me some this is probably in your data set you'd have like real values here, but this is just to illustrate how to have this. So here I'm creating a second data frame, again in tidy format, where you have one column and one variable, right? One variable for each column. And so I've got data frame x equals xp, y equals yp. So this is kind of my x points and y points, right? And so back here, I've created my plot. My plot is ggplot, where I've the data source is the function data frame, and I've mapped x to x and f of x to y. Okay, that's in my plot. That's this plot. This is what's stored in P. And then so I take that, I basically just take this exact line here, or I just have P, and I'm going to add, and I'm going to say add some point geometries. And for the point geometries, the data comes from a different data frame. It comes from the data frame df underscore points. Okay? And then, and the way we are going to graph the point geometries is we're going to map the x to the x-axis and the y to the y-axis. Okay? So this is almost like calling a separate ggplot, but you are not, because you are putting it in the same plot. So you only call ggplot once. Okay, that's to create the initial plot with the initial data frame, but then, and so so here, this geom line where I don't have a data mapping, I don't say data is equal to something, this geom line will assume or use the data in the original ggplot. Here I want to add additional geometries from a different data set. And so I say here is another geometry point, and I've got data equals df underscore points. If I wanted to, I could add another line graph or whatever it is. You just say you want to add an additional geometry to your plot using the data frame from whatever source you have. And so when you do this, you still have the original line, and then this is just kind of the random points that I've plotted, right? At 0, at 1/2, 1, 1.5, 2, 2.5, and so on and so forth. And the height is just some random normal value. Okay. Yes, question? It doesn't matter, okay? In terms of speed, I'm not 100% sure. It's what's often recommended is you minimize the amount of copying and pasting, okay? Because if you're consistently copying and pasting code, then if you decide you want to make a change later, you've got to change it in every single place that you've pasted that code, right? If you know that this is going to form your base plot, it makes sense to store it as P, and then later on, if you want to change it, you can just change it in one location, and it will change to every other location that references that object P. So as a way to minimize copying and pasting, I do think this is good. Okay, so we've got this. All right, and then if you wanted to add, say, line segments, okay, so this is different from geom underscore line. There's geom underscore segments, okay? Segments basically, well, they plot line segments onto your plot. The way a line segment is defined by two coordinate pairs, a start point and an end point, right? So the data frame for the segments needs to have 4 columns. It needs to have an x1 and an y1 column, x1 column and a y1 column to define the starting point, and it needs to have an x2 column and a y2 column to define the ending point, okay? And so here I've just created, I just said I want to create 8 line segments where, and then the starting points are going to be kind of just 8 random values drawn from the normal distribution, and the ending points are 8 random values drawn from the normal distribution. I throw them all into a data frame with those 4 columns. And then for geom segment, again, all of this is in the ggplot reference. I'm saying do an aesthetic mapping where you're going to map x and y to x1 and y1, and then the end point, x end and y end, get mapped to x2 and y2. And we say the data is coming from the data frame df underscore segments. Okay. So again, you can have additional sources of data or mix different data frames, and you just, for each geometry, you just say, this is where my data is coming from. And so here we have our cosine graph, the random points that I've done, and then these are 8 random line segments that I've plotted, okay? Of course, your data will certainly have more structure than these random points here, but I think this is at least illustrative of how you would kind of combine these different geometric elements into the same plot. And that's what we have. Okay. Are there questions? Are we good? Okay, we'll end here for today, and we'll see you guys on Wednesday.